So in this example, we're going to be graphing a quadratic equation from intercept form. And remember, a quadratic equation is in the shape of a parabola. Intercept form is when we actually have the equation factored out into two binomials, as you see here. So our general form for a quadratic equation in intercept form is f of x equals a times x minus p times x minus q. And this is called intercept form because the p and the q represent your two x-intercepts, the two places where the parabola is going to intersect the x-axis on your graph. So the first thing we're going to do is we're going to identify the intercepts, or the roots, or the zeros. There's multiple terms for these values. So in our intercept form, we notice that we have x minus p and x minus q. So let's look at the equation that we're given for this particular quadratic, and we notice that we have x minus 4 as our first binomial factor. Our first binomial factor being x minus 4 means that our first intercept is 4. That's going to be our p-value, because in the formula, or in the intercept form, x minus the p-value gives you the first intercept. So minus 4, so the p-value is 4. For q, we have x plus 8. And remember, it's what you are subtracting that gives you the q value. In order for us to get plus 8, we actually have to subtract a negative 8. So negative 8 is our q value. So we have now just identified our two x-intercepts. And the coordinates for those will be 4, 0 and negative 8, 0, because at the x-axis, the y-coordinate is always 0, because we're not up or down. We are actually at 0. There has been no movement up or down. So I'm going to go onto the graph and I'm going to plot my two intercepts. The first one is at negative 8, 0. And the second one is at 4, 0. So what I've just done is plotted the two intercepts for my parabola. This is the place on the graph where my parabola is going to intersect the x-axis. So now that I've found my intercepts, the next thing I'm going to do is I'm going to find my axis of symmetry. Every quadratic, every parabola has an axis of symmetry. And what the axis of symmetry is it's a vertical line that actually goes right through the center of the parabola. It actually passes exactly halfway between our two intercepts. So in order for us to find the axis of symmetry based on the information we currently have, we are actually going to take the average of our two intercepts, the halfway point. So p plus q divided by 2, and that's x equals, because this is going to be a vertical line, so x equals, and let's plug in our values. We have 4 plus negative 8 divided by 2. 4 plus negative 8 gives us negative 4 divided by 2, which gives us negative 2. So that means on our graph, our axis of symmetry is going to be a vertical line at x equals negative 2. This is the line that is going to divide my parabola exactly in half. So now that we found the two intercepts using the binomial factors, and we found the axis of symmetry, the next thing we're going to find is the vertex. And remember, the vertex in a parabola is either the maximum point or the minimum point, depending on which direction your parabola opens. Now we figure that out, the direction that it opens, using the a value. So we look at the a value in our particular example, and it's positive 1/4. The positive a value indicates that the parabola will open upward. Therefore, our vertex will be a minimum point. It's going to be the lowest point on our graph. If the a value were negative, that would mean that the parabola would open downward, and our vertex would then be the highest point, or our maximum. So here, because the a value is positive, we have a parabola that's going to open upward, and our vertex is going to be our minimum, our lowest point. One thing we know about the vertex is it actually lies on the axis of symmetry. So since we know the vertex is on the axis of symmetry, we know that it will have an x value of -2. It has to in order to be on this line. So we're going to take the original equation and we're going to plug in the x value of -2 for x and see what my output is to find my y value. So we have 1/4, and instead of x minus 4, we're going to plug in -2 for x, so it would be -2 minus 4, and -2 plus 8. Once I solve this expression, that's going to give me my y value of my vertex. So I have 1/4, I have -2 minus 4, which gives me -6, and -2 plus 8, which gives me +6. When I do this computation, I get -6 times +6, which gives me -36. And when I multiply that by 1/4, I get -9. Therefore, my vertex is at the point -2, which is the x value I plugged in based on my axis of symmetry, -9. So I can now go over to the graph along my axis of symmetry and place my vertex at -2, -9. As you can see, the parabola is starting to take its shape. We see the vertex, which again is a minimum value because the parabola opens upward because the a value is positive, and we see our two intercepts. There is, however, one more value that we can find that will make our graph as accurate as possible, and that is the y-intercept. Now, as you look at the graph, you see that we have x-intercepts. And at the x-intercept, the y value is 0. For the y-intercept, our x value is going to be 0. So what we're going to do is take our original equation, and we're going to substitute 0 in as our x value to find out what y value we get. So I have 1/4, 0 minus 4, 0 plus 8. And as an expression, I have 1/4, 0 minus 4 gives me -4, 0 plus 8 gives me 8. So when I multiply these factors, I have 8 times -4, which is a positive times a negative, that gives me a -32. And when I take 1/4 of -32, I get -8. Therefore, my y-intercept is at the point 0, -8. So on my y-axis, I put a point right here at 0, -8, and that is my y-intercept. Now I'm ready to completely draw my quadratic or my parabola. So the parabola is going to behave this way. It'll curve, and it'll keep going, and it'll do the same thing on the other side. So once again, what we've just done is graphed a quadratic from intercept form being two binomial factors which provide us with P and Q, which are our two x-intercepts. Once we know our x-intercepts, we find the axis of symmetry by finding the average of those two intercepts, because we know the axis of symmetry passes right down the center. Once we know the axis of symmetry, we can find the vertex because we know the vertex sits on the axis of symmetry. So we will plug the x value of the axis of symmetry into the original equation to find the y value of the vertex. Once we know the two x-intercepts and the vertex, the only other value we can find is the y-intercept. That will help us. So we will plug in 0 for x, because everything on the y-axis has a 0x coordinate. And we plugged in 0, and our output came out to -8, which means our y-intercept is at 0, -8.